To understand the projectile motion, you must have the knowledge of kinematics equations as well as the basics of vectors. Let's say a stone is thrown upward with a certain velocity, then it's going to go like this and then come back due to the effect of gravity. As the gravitational pull is there in the downward direction, this stone will follow a path like this. But what if we have thrown it at a different direction? Say in this direction you are throwing the stone. It's going to go like this, and you call this path as a parabolic path. If you are throwing the stone at an angle with which is not 90 degree, other than 90 degree, any other angle with the horizontal, then it's going to follow a parabolic path, and we call this path as a trajectory, or you can call it as a projectile motion. To understand the formulae related to projectile motion, we'll first consider an example. Here we have a building, and you can say it's 40-meter high, and from the top of the building, a stone is thrown with a horizontal velocity 5 meter per second. So I have shown the direction of the velocity, and it will follow a trajectory like this, and it's again a parabolic path. I will tell you, it's not exactly the one which we have seen, but it's here we have it's starting from the ground like this, and it's starting from here somewhere, from the building like this. Okay, the question is at what distance from this building the object or the stone is going to fall. So this distance we call the range, or I call it as r, we have to find. This is a very basic question, and from this we'll try to understand the concept when an object is under the effect of two motions. Since the stone is given a velocity 5 meter per second in a horizontal direction, the stone tries to move in a horizontal direction, but at the same time, since there is gravity acting downwards, so there is a gravitational pull downwards, the overall effect of the stone is seen like this. So these are the two motions, and to solve this question, you just consider both of these motions independent. That is called as law of independent motions. Means even if the stone is under the effect of these two motions, it is simply going in the horizontal direction as if this vertical was not present, or it is moving in the vertical direction at the same time as if this horizontal was not present. But as both of these motion are there, the effective trajectory is seen like this. Okay, it will be more clear from the numericals which we are going to do now. We have to find this r here. For that, as I said, we are going to consider the horizontal and vertical motion completely independent of each other. And remember one more thing, when you consider these two motions independent, just observe that whether they are accelerated or non-accelerated or uniform motions, we can say, because we use different formulae for both of them. And here in the horizontal direction there is no force, therefore the horizontal motion is going to be a uniform motion. So you can say wherever you take this point, velocity 5 meter per second is not going to change, it's constant all over, it is 5 meter per second. But what about the vertical velocity? Initially the object is not given any vertical velocity, therefore the initial vertical velocity is 0, but as it approaches the ground, the velocity goes on increasing. So the vertical velocity is not constant, because the vertical motion is the accelerated motion. And when we say that these two motions are independent, or the object is moving independently under the effect of these two motions, there is one common thing, and that common thing is the time required. Because for the time the object is moving vertically, for the same time the object is also moving horizontally. That's why the time required for the object to reach from this point to this point, the bottom, is same. It's the same for which the object is moving this horizontal displacement here, this much. I have written this expression for the vertical motion of the object, and you can see here that object is not thrown vertically downward, it's just released because it has been given a horizontal velocity. This 5 meter per second is simply the horizontal velocity here, and therefore the initial vertical velocity is simply zero. So as I said, you should know basics of some basics of kinematics equations for this. So for the vertical motion, I will say the u, that is the initial velocity, is zero, and it's moving under the effect of acceleration. So I'll just put a plus over here. Actually, it should be a plus because it is coming downward. It is a positive acceleration, and you have to find the time required because time is the common link from both of them. So the plan is, from the vertical data, you calculate the time required for the object to go from this point to this point, and for the same time the object is moving from this point to this point horizontally. So you can get this horizontal range because it is a uniform motion simply by taking the velocity into time. This formula is enough to find the horizontal range because it is a uniform motion, and you simply consider the two motions different, and the time is the common factor between them. To find the time, we have taken this vertical motions equation, and s is the height of the building. From this is the vertical distance the particle covers. So I have written that s equals to 40 meters, u is the initial velocity, which is 0, and acceleration is the gravitational acceleration, which I am going to take uh, approximately 10 meter per second square. And we'll use this kinematics equation here, that is s equals to ut plus half of at square. And since s is 40, we'll just put the values in it, and you're going to get 40 equals to half gt square, and t square equals to 2 times 40 over this g, which is 10. And by the simple calculation you can do it. So 10 4s are 40 and 4 2s are 8, and since it is t square equals to 8, you get t equals to root 8. So that's the time required. That's the time required for the object to come from this point to this point down bottom. But at the same time the object is moving horizontally also, so it is not going to reach here but here. But how much is this distance now? For the same time the object is moving with 5 meter per second in the right side. That is why for the horizontal motion I've written this equation, which we call r, or the range, equals to velocity multiplied by time. And this velocity is the constant velocity, it is not going to change because the horizontal motion is uniform. I'm using this formula, which is distance is equal to speed into time. The speed is given as 5 meter per second, and the time we have calculated, that is from the vertical motion, is root 8. So it comes out to be 10 root 2. So you can calculate this range by this simple formula v into t, where t is calculated from the vertical motion. The final answer comes out to be 10 root 2 meters. So the particle or the stone is going to hit the ground at a distance 10 root 2 meter from the bottom of the building. For projectile motion, we use a similar concept. When you throw an object with a velocity u at an angle theta, then it will have these two velocities. Say u cos theta, u sin theta. I have resolved this component, resolved this u in its components as rectangular components as u cos theta and u sin theta. Now, in its journey, in the journey of this particle like this here, it's going to have these two velocities. But hold on, are they uniform or non-uniform accelerated? That you must see. Since vertically the object is under the influence of the gravitational force, the vertical motion is definitely accelerated one, while the horizontal motion is it's constant because there is no horizontal force here. It's going to be a uniform motion. So in simple words, you can say that at this point the object has these two velocities. At this point it has this all horizontal as well as vertical components at all the points, but at every point the horizontal component is same. It is u cos theta here also, here also, here also. You can simply say that the horizontal component is going to be u cos theta everywhere, here also. But what about the vertical component? The vertical component is simply going to change because as it is being pulled downwards, therefore the object will eventually stop. So at this point, maybe it will have only horizontal. This is the highest point. This is the highest point. You can call it edge, the height. At this point, only horizontal component is present and vertical component is not present. It has become zero, as we know that when you throw the object upwards, its velocity becomes zero at the highest point and then it starts coming downward. It's a similar situation. Just consider the vertical motion. The vertical motion starts with this speed u sine theta, then the object is going to attain certain height and after that is going to come back like this. So this is the vertical motion and it is independent of the horizontal motion. At the same time you give this object the horizontal motion and then you're going to look at it like this projectile here. Now here also we have a similar situation as that of the previous example. We have a vertical motion, we have a horizontal motion, and the common link between the two is the time. The time for which the object is moving vertically, for the same time the object is moving horizontally. So if I have to find this range here, range r, then it will simply be v multiplied by t. Now what is v? V is the horizontal speed. That horizontal speed is simply u cos theta multiplied by the time required. Now what is this time? This time can be calculated from the vertical motion as we did in the previous example. So we'll calculate the time from the kinematics equation of the vertical motion. For the vertical motion, I have written this data here. And if we look in this diagram where we have vertical initial speed as u sine theta, and this is that u sine theta I have taken as the vertical initial speed, and since it is moving upward, you have to take the acceleration as negative because the force is acting downward. So the object is going like this and coming back like this. So for this vertical motion, the acceleration is going to be negative g. And what about this displacement? Since the object starts and comes back to the same vertical point, vertically it is at the same level, the displacement is simply zero. See, the object is going like this and coming back over here vertically, it is coming back at the same level. So the vertical displacement is zero. Since we are considering only the vertical motion, remember, you can say that the displacement is zero here, and using this we can find the time like this. We'll use another, again the same equation, s equals to ut plus half at square, where s is 0, u is u sine theta, and acceleration is minus g. So that's why this minus half of g I have put here into t square, and by simple algebra you can this shift this the other side, and u sine theta equals to t, and then you can simply cancel it. I think, yeah, you can simply cancel this thing, yeah, like this one will get cancelled, and you can write t equals to this 2 will go that side, so 2 times u sine theta over g, and you get this formula for that. So t equals to 2 u sine theta over g. This is a very important formula, which is also known as the time of flight, right? So this is the time of flight, means the time required for the object to go or to cover that entire journey is the time of flight. So remember, they are represented by capital T also. This is the time of flight. 2u sine theta over g. This theta is the angle with which the projectile was launched, or this is also called as angle of projectile. Now, once you have got this time expression, we can use the horizontal motion expression as r equals to v into 2t. Remember, for this we said that the range is simply u cos theta multiplied by t, because the horizontal velocity is going to remain constant. So we will use distance is equal to speed into time, and the time we have calculated as the time of flight is 2u sine theta over g multiplied by this u cos theta. So we will simply get this 2u square sine theta cos theta over g, and by a simple trigonometric ratio you can put these things together, 2 sine theta cos theta, which is simply sine 2 theta. So the formula for the range becomes u square 2 sine theta cos theta, which is 2 sine 2 theta over g. I'll just write it. This one. This is the formula for the range. So you got the formula for the time of flight and now for the range. And using the similar expressions, you can find the formula for the maximum height as well. Goodbye.